Hello, my name is Fatih Furkan Akec, and this is machine learning assignment collaborative filtering recommender systems. In this exercise, we will implement collaborative filtering to build a recommender system for movies. Let's run the package. Okay, here is notation. And recommender systems. The goal of collaborative filtering recommender system is to generate two vectors for each user. A parameter vector that embodies the movie taste for a user for each movie, for a feature vector of the same size which embodies some description of the movie. The dot product of the two vector plus the bias term should produce an estimate of the rating the user might give to that movie. The diagram below shows details how these vectors are learned. And existing ratings are provided in matrix form as shown. Y contains ratings 0.5 to 5 inclusive in 0.5 steps. 0 if the movie has not been rated. R has a 1 where movie has have been rated. Movies in rows, users in columns. Each user has a parameter vector W user and bias. Each movie has a feature vector X movie. These vectors simultaneously learned by using the existing user movie rating as training data. One training example is shown above. W1 times x1 plus b1 equals 4. It is worth noting that the feature vector x movie just must satisfy all users, while the user vector w user must satisfy all the movies. This is the source of the name of this approach. All the users collaborate to generate the rating set. Once the feature vectors and parameters are learned, they can be used to predict how user might rate an unrated movie. This shown in the diagram above. The equation is an example of predicting a rating for a user on movie 0. We will implement the function coffee cost function that computes the collaborative filtering objective function. Here is the matrices X, W, and P, and the ith row of X corresponds the feature vector Xi for the ith movie, and the jth row of W corresponds to one parameter vector Wj for the jth user. Both Xi and Wj are n-dimensional vectors. For the purposes of this exercise, you will use n equals 10, and therefore Xi and Wj have 10 elements correspondingly. X is a nm times 10 matrix, and W is a nu times cross 10 matrix. Okay, let's load the data. Let's print it. Collaborative filtering algorithm. we will complete the cost function to compute the cost function collaborative filtering, and the collaborative filtering cost function is given by like that, j x2 x and m minus 1 w0 b0 and w u minus 1 and b and u minus 1 equals to that, and the first summation in 1 is for all I and j where r I and j equals 1, and could be written like that, this function plus regularization part. We should now write coffee cost function, collaborative filtering cost function, to return this cost. For loop implementation, start by implementing the cost function using for loops. Consider developing the cost function in 2 steps. First, develop the cost function without regularization. A test case that does not include regularization is provided below to test your implementation. Once that is working, add regularization and run the tests that include regularization. Not that you should be accumulating the cost for a user j and movie I for if ri j equals to 1. Okay, let's start coding in here. For j in range nu w equals to uppercase w and j and b underscore j equals to b0 and j, and another loop for I in range nm x equals to uppercase x I and uppercase y no lowercase y equals uppercase y and I to j r equals to uppercase r I j and j increment equal to numpy square r times numpy dots wx and plus b underscore j minus y. out of loop. Define j increment equal lambda underscore times numpy square or numpy sum, and inside that numpy square of w and plus numpy sum of numpy square of x, and j equals to j over 2. Let's run it. Let's run that. We have an error in there. I don't understand that. Let's check the code. Not same as mine, but let's try to copy from that. Let's take that. There's little changes in here. Let's run it like that. I don't know, maybe I have an error. Yes. I used the j increment lambda underscore line, but maybe it's not correct. It's just fine without using that. Okay, let's continue. And here we have an error. Let me check for that error and I will continue with. Okay, I found my mistake. I used underscore j in here, but like that it works just fine. And after that vectorized implementation, it's important to create vectorized implementation to compute j, and the linear algebra utilized is not the focus of this series, so implementation is provided and we run it. Let's run it too. Okay, and learning movie recommendation. In the cell below, we can enter uh, our own movie choices. The algorithm will then take the make recommendation for you. We will filled out some values according to our preference. But after uh, we have things working with our choices, we should change this to match our taste. A list of all movies in the dataset is in the file movie list. We can look at and change the movies in here and rate the movies, but for now let's run it like that. The movies looks fine, and here's the ratings listed. And now let's add these revives to y and r to normalize ratings, and prepare to train model. Initialize the parameters and select the ADAM optimizer. Now train the collaborative filtering model. This will learn the parameters x, w, and b, and operations involved in learning w, b, and x simultaneously do not fall into the typical layers offered in the TensorFlow neural network package. Consequently, the follow used in Course 2 model, compile, fit, predict are not directly applicable. Instead, we can use a custom training loop. Recall from earlier labs the steps of gradient descent. And let's run it. And recommendations. Below we compute the ratings for all movies and users and displays the movies that recommended. These are based on the movies and ratings entered as my ratings above. To predict the rating of movie I for user J, you compute WJ, XI, and BJ. This can be computed for all ratings using matrix multiplication. Okay, in here, original and predicted ratings. In practice, additional information can be utilized to enhance our predictions. Above, the predicted ratings for the first few hundred movies lie in a small range. We can augment them above by selecting from those top movies that have high average ratings, and movies with more than 20 ratings. These sections use a pandas date frame which has many handy sorting features. And let's run it. Here's the movie's title and number of ratings, mean rating and predicted rating of these movies. Okay, we implemented the useful recommender system. Thank you for watching. I will make the assignment 2 from now. See you later.